Hi, and welcome to our lesson today. Today we are going to talk about simplifying complex fractions. This is more of like a continuing session or like a lesson from our previous lesson that we did on Saturday, because we're going to do more practice problems on whatever we learned on Saturday. So today's going to be nothing new in the sense that, like I just said, that we're just going to be doing practice problems with simplifying rational expressions. So these are the 5 practice problems that we are going to work with, and we're going to work with in the order they're given in there. So let's get started. So this was actually our first problem that we are going to work on for today. And for this problem, interestingly, what I have is that I have a fraction, I have another fraction, and I have like 4 fractions. So I'm actually working with 4 fractions in here, and all those 4 fractions are actually part of a bigger fraction, and which is what makes it a complex fraction. So I have 4 smaller fractions as part of a bigger fraction. Okay, so there are actually 2 approaches that you can take to solve this problem, and I'm actually going to show like both of the approaches. So in the first one, what I'm going to do is that I'm going to find the LCD, right? So what I'm going to find is that I'm going to find the LCD of all the denominators of the smaller fractions that I have in there. So in total, I have 4 smaller denominators in there, right? So then from the 4 denominators of the small fractions that I have in there, what is my LCD? I take a look at my first denominator and I see x plus 1. I take a look at my second denominator, I see x plus 2. I take a look at my third denominator, well, I see x plus 2 as well, and I already have x plus 2 as part of my LCD, so I'm not going to include any more x plus 2's in it, because it's the least common denominator, right? And then I say x plus 1, well, I already have x plus 1 as part of my LCD, so I don't have to include any more x plus 1's in that. So this is actually my LCD that I'm going to use to multiply all the smaller fractions in there. What I'm going to do is, like I just said, I'm going to multiply each of the smaller fractions using my LCD. So what do I have to do for that? I'm going to bring down everything I have in the top. So my LCD was, like just I said, was x plus 1, x plus 2. And like I just said again, was that I'm going to multiply each of my smaller fractions in there using my LCD. And it doesn't really matter which order you write them in. So now that I have that, what I'm going to do is that I'm going to try to work them in pieces, okay? So what I'll try to do is that, so I'm going to work with this one here, and I'll work with this one there, work with this one here, and I'll work with this one there, right? And then when you do that, you should be able to notice something. And what should you be able to notice? Well, if you take a look at this one here, you see that you have x plus 1 and you have x plus 1. You can cancel them out because they're common factors, right? And if you're trying to multiply rational expressions, you can cancel common factors. Then what are the common factors in this one? Well, the common factors that I see in that one are surprisingly nothing but x plus 2 and x plus 2, right? So I can cancel them out. And if you take a look at this one in here, you can cancel x plus 2 in here as well. And from this one, you can cancel x plus 1, x plus 1. Because again, if you are multiplying rational expression, you can always cancel out your common factors. And now whatever you are left with what you basically do is that you try to multiply across, right? So I'll try to multiply across whatever I have left with in this box. And whatever I'm left with is that 6 times x plus 2, right? And then in here, what I'm left with is negative 4 times x plus 1. Right? And then in the bottom here, whatever I'm left with is that 5 times x plus 1. And then in this side, I'm left with 3 times x plus 2. Right? So that is everything that, so far, I multiplied whatever I had left with across. Right? So that's where we are so far with our simplification process. So now what I have to do is that I have to simplify. And how do you simplify in this type of situation? Well, what you do is that you distribute. Yeah. So now if I'm trying to distribute, 6 times x should give me 6x plus 12 minus 4x minus 4. Because if you're trying to multiply a positive number with a negative number, the result is negative. And then the bottom, if you take a look, it's 5x plus 5 minus 3x minus 6, right? And then if you do that, what you are supposed to do is that you're supposed to combine the like terms. And how do you combine the like terms? Well, you at first identify the like terms. What your like terms are there, right? And then what are your like terms in there? If we take a look, 6x, negative 4x, they're like terms, right? And then what else do you see as your like terms? Well, I see 12 and negative 4 in there as my like. So now that I have identified my like terms, I go ahead and combine them, right? So 6x minus 4x, that should actually give you what? And then 12 minus 4, that should actually give you positive 8. And if you take a look at the bottom, and if you're trying to identify the like terms, you should get 5x in there, negative 3x in there. They're like terms. And what else? What other like terms should you be able to see? Well, 5 and negative 6. They should be your like terms. So then what happens if you combine them? Well, if I combine 5x minus 3x, I should get 2x at the bottom. And then 5 minus 6 should give me negative 1. And now, with this fraction, what you should be able to see is that you can further simplify this fraction. And what you can do is that for the top, you can factor out the GCF. My GCF was 2. And then if I divide each of my terms with the GCF, I should get x plus 4. And in the bottom, you cannot simplify it any further. And this in here is your final simplified answer. Okay? So now we are going to move on with our second practice problem that we have. So, but before we move on to our next problem, I told you guys that there are actually like 2 methods or 2 ways that you can approach this problem. So I just showed you the first method or the first way. Now I'm kind of like show you the other way that you can solve this problem. This is like kind of like a lengthier or like a more expanded way. But this is again another way of like doing this problem, okay? So what I'm gonna do is that I'm gonna combine my fractions in the top. So the numerator actually has 2 fractions, and I'm gonna combine all those 2 fractions in the numerator, and I'm gonna make that into 1 fraction. How do I do that? Well, I see 6 over x plus 1, and I should be multiplying that with, the top and the bottom using x plus 2. And then I have negative 4 over x plus 2. And I know what I should be multiplying that with. I should be multiplying that with x plus 1. Right? And now that you did that, you just created a common denominator, right? Now, both of your fractions have the same denominator. And now what I'm going to do is that I'm going to make the denominator like this denominator. I'm going to do the same thing as I did. You can work your way like simultaneously, like you can do whatever you did to the top to the bottom, or you can like do it separately, your wish, but then I prefer to like work simultaneously. So then what I'm going to do is that I have 5 over x plus 2, and I'm going to multiply that using what? X plus 1, x plus 1. And then I have negative 3 over x plus 1. And guess what I should be multiplying this with? You guessed it right, x plus 2. Right? Now if you take a look, both of your denominators and numerators, they have the exact same fractions. Right? Now what you should be doing is that you should be combining the numerators, like numerator of the bigger fraction and the denominator of the bigger fraction. In other words, you'll be working with the smaller fractions, right? So then how do you do that? Whatever you have, you multiply across, right? So 6 times x plus 2 minus 4 times x plus 1, right? Now that you have that, whatever you had in the denominator, you have to do the exact same thing with them. So I have x plus 2 5 times x plus 1 minus 3 times x plus 2. Right? You still have a fraction as your numerator of your like bigger fraction and a fraction in the denominator of your bigger fraction, right? Which is still making it complex to work with, right? But still, like, it's still doable, right? We can still do it. So now there are actually like 2 ways you can go about it. You can, like, you know, multiply the numerator of the bigger fraction using the reciprocal of the denominator, or you can simplify first before you want to do that. Either ways, if you do it, you should be able to get the correct answer. So what I'm gonna do is that I'm gonna simplify, and at the same time I'm gonna multiply the numerator using the reciprocal of the denominator, right? So what I'm gonna do is that I'm gonna distribute, right? So if you take a look at this part, right? At this part, I'm gonna distribute. So I get 6x plus 12, and I get minus 4x minus 4 over my denominator, which is this. Now what I'm gonna do is that I'm gonna change this division sign into multiplication sign. And I'm gonna flip this fraction that we have in there. So my denominator goes to the top. And my numerator becomes my denominator, but what I'm gonna do is that I'm gonna simplify while I write that. I'm gonna write 5x plus 5 minus 3x minus 6. Now what are you supposed to do? What should be your next step? Now you should be able to figure out your common factors. Because again, you are multiplying rational factors, rational expressions, and you should be able to figure out your common factors, and then you should be able to cancel them out. So then I have that. I can cancel them out. So now, whatever I'm left with, I'm supposed to multiply across. So then I should be able to see, but then while I'm trying to write this down, right, I will be simplifying this. So I'm trying to do like 2 things at the same time. So I should be taking a look at this, and I should be trying to figure out the common terms and combining them. So I see 6x negative 4x. That should give me 2x. And then I also see positive 12, negative 4. Combine them, that should actually give me plus 8. Right? And if you take a look at this part here, look at the like terms, 5x, negative 3x. That should give you positive 2x. And then you have 5 minus 6. That should give you plus 1. And like we did for the previous problem, you should be able to factor this one. And how do you factor this? Well, you factor the GCF, you divide each of the terms using your GCF, and you're left with this answer. Please, please, please do not do this. Do not do this. That is wrong. You cannot cancel the 2 at the denominator because that 2 is multiplied with the x and the 2x is added to the 1. You can't cross them out. Please do not do this. Whatever you have in there, that is your final answer. So this. Okay. So now we're finally gonna move into our next question that we have. Again, you guys can pick either method that you want to use. I'm fine with both as long as you get the correct answer. So, yeah. So this is our second problem in here. And the thing with this one is that I see a fraction here. I see another fraction here. And I see one fraction here. So my denominator necessarily doesn't have 2 fractions this time. It has only 1 fraction. However, my numerator, like the previous problem, has 2 fractions, right? And this is still a complex fraction. So what do I do with this one? What I'm planning to do with this one is that I will try to multiply all the smaller fractions in this one using the LCD of the smaller fractions. And now, just by looking at it, I really don't know the LCD, and I'm definitely not multiplying all the smaller fractions using this trinomial and these 2 binomials, because that's gonna lead to like a more complex situation. We're not gonna do that. What we're gonna do instead is that we're gonna start off with factoring the denominator of the fraction that we have in here. Right, so then what happens when you factor that? Well, I'm gonna write whatever I have in the numerator, and now I'm gonna factor that. And how do I factor a trinomial? And that's what I should get if I factor the trinomial, because 4 plus 2 gives you 6 and 4 times 2 gives you 8, right? And now that you have factored it, now you should be able to figure out your LCD, or least common denominators. Well, I find the LCD to be x plus 4, x plus 2, and x minus 3. That's my LCD, and I'm going to multiply all of the smaller fractions using my LCD. X plus 4, x plus 2, x minus 3. And I'm also going to multiply this fraction that I have in here using the LCD. X plus 4. And I had x plus 2. And I had x minus 3. Right? And then what happens if I do that? Well, now I'll try to like work individually, like in pieces, with all of the smaller fractions that I have in here and the LCD that I multiplied with them. And then let's try to work with them in pieces. That's my first piece, my second piece, and the last one. Right? So then if I'm like taking a look at them as pieces, what do I notice? What should I be able to see? Well, I see that I'm multiplying rational expressions. And we have learned how to multiply rational expressions before. We take a look at the common factors and we cancel them out. Well, if you take a look at the common factors, if you're trying to figure out the common factors in this scenario, what do you see? What are your common factors?
X plus 2.
Yep. And then what is my common factor in this one?
X minus 3.
Yep. I can cancel them out. And what is my common factor in this one?
X plus 4.
And
x plus 2.
Yep. So you have to cancel out all the common factors, right? Then only you have the simplest form of the fraction. So then I have canceled out all of the common factors, and guess what happened? Something very magical happened. Well, what I'm able to see now is that I got rid of all the smaller denominators. Like the denominators of the smaller fractions, they all got canceled. So now whatever I'm left with, I'll try to multiply across. So from this part, I have 4 times x plus 4 times x plus 2. And in this one, I have negative 2 times x plus 4. So what I'm essentially doing is that whatever I'm left with after canceling out the common factors, I'm multiplying them across, okay? And then in here, I have 8 times x minus 3, right? And now that you have that, what should be your next step? What should you do as your next step? Well, you should be simplifying them. And how do you simplify this? Well, as my first guess, what I'm thinking is that I should be probably distributing. So distribute, or the other thing that you can do if you don't want to like distribute and then multiply, you don't have to do it. You can FOIL them. These two binomials, you can FOIL them and then multiply them using 4. The same scenario in this one, you can FOIL this and then multiply with the negative 2, which is what actually I'm gonna do. So if I FOIL them, I get x squared plus 2x plus 4x plus 8. And for the second part, I have x squared minus 3x plus 4x minus 12. Right? That's what I have. Now that I have that, what is my next step? Well, as my next step, I should be combining the like terms. Let's combine the like terms in the parentheses. So in here, I have 2x and 4x. And then in here, I should be able to see them, and that should give me x minus 12. And now you can obviously distribute. Also, if you try to follow PEMDAS, in PEMDAS you do parentheses first. In that sense, you can also like FOIL the binomials first, like I did. And now if I'm distributing, I get 4x squared plus 24x and now we do the same thing like we did before. So now I should be looking for like terms in here. And what do I see as my like terms? Well, as my like terms, I see this one.
Can I say?
Of course you can say. Yeah, what are the like terms in here?
4x squared minus 2x squared.
Yep, that's your first pair of like terms. And then what else do you see as your like terms?
24x minus 2x.
Yep, and what else do you see as your like terms?
32 and 24.
Yep, they're all your like terms that you should be combining, okay? So now, if I'm trying to combine them, I do 4x squared minus 2x squared. That should give me 2x squared, right? And then plus 24x minus 2x. That should give me minus 22x. And then plus 32 plus 24. That should actually give me 56, right? And whatever I have in there, in the denominator, I bring that down. And now what is my next step? Well, there are actually 2 ways you can do this. You can do trinomial factoring for this, or you can factor the GCF first And then you can do the trinomial factoring. Yeah, so now that you have that, how do you factor this? How do you factor this trinomial? How do you factor the trinomial?
So for the first parenthesis, it's going to be x minus 7, x plus 4.
So
X minus 4, x minus 4.
Yep. So now you have factored them. Now that you have factored them, I mean, you should have been able to see it from here, right? I mean, you can simplify them in there. If not, you can simplify them in this step. It doesn't really matter. I think I should have simplified it before. And then if I simplify 2 and then 8, I should be able to get what?
1/4.
Yep. Right? And then now, instead of writing this, I'm going to write my 1/4 in there. And that in there is your final answer. It cannot be simplified any further, and that is your final answer. Okay? So this is our third problem on our list. And how do you do this problem? What should be our first step or approach to this problem?
Multiply 2.
Yeah, we multiply.
With x minus 4.
Yeah, so we multiply everything, all the smaller fractions, using the LCD, which in this case is just x minus 4. Right? So I multiplied everything in there, like all the fractions, using my LCD, which was x minus 4. And now that I have done that, what should I be doing? I should be probably working in pieces if you guys want to do that.
Okay, so
yeah, you can say it.
So for the first fraction, x minus 4 and x minus 4 cancels out. And then for the next one, you have to multiply 2 times x minus 4.
Yeah, so what we're going to try to do is that we're going to try to like cancel everything. And then if it cannot be canceled, then we just leave them like that. So then this gets canceled, right? And now, whatever I'm left with, I'm trying to multiply across. And then for the first part, I'm not really left with anything. So 6, right? Plus, in the second one, I'm left with 2 times x minus 4. With this one, I'm left with 2 times x minus 4 minus 4. Right? Do you see how that, like, you know, not very pleasant looking fractions turn into a very nice looking one, right? And now what are we supposed to do as our next step? We are supposed to simplify. And then for this one, I'm just going to distribute. And even for this one, I distribute it. Notice, even though you had the same thing in the top and the bottom, like x plus 4, you cannot cancel them. Please, please do not do that. And now what I'm supposed to do? Well, now I should be looking for common terms and see if I can combine them. Well, I see 6, I see 2x and 8. I can combine them. 6 minus 8 gives me what? -2 plus 2x. And in the bottom, I have 2x. I can combine them. And now I should be able to factor out the GCF. Well, in here, my GCF is going to be 2. In here, my GCF is going to be 2 as well. and I see a 2 at the top, I see a 2 at the bottom. Now you can cancel them because both of them are multiplied to something, right? So I cancel them, and I'm just left with x minus 1 over x minus 6. And that is your final answer for this problem. So this is actually our fourth problem on the list, and we do it the same way as we have been doing our previous problems. We figure out the LCD, and what is our LCD for this one? So the LCD of this problem is actually what?
X minus.
Yep. Right, and then what do? You multiply every single smaller fraction using the LCD, right? I know it's a big LCD this time, but just bear with me. Right, so once you do that, what do you do as your next step? You look for the common factors, yeah?
Yeah, you look for the common factors and then you cross them out.
And then what is the common factor of this one?
X minus 2.
Yep. How about for this one?
X minus 1.
Yep. And how about for this one?
X plus 1.
Yep, and then there was another fraction that I kind of forgot to write the LCD for. And for this one, it should have been x plus 1, x minus 1, and x minus 2. And what is the what is the common factor for this one?
X minus 2.
Yeah, and now that you have canceled out all the common factors, you just got rid of all the denominators of the smaller fractions, right? So now I have to write that as one fraction, or now I will be at least able to write them as one fraction. So now whatever I was left with, I just multiply across in this part, right? So it should be 3 times x plus 1 and then x minus 2, and then for this one, it should be 4 times, negative 4 rather, times x plus 1. And for this part, it should have been 5 times x plus 1. And for this one, it should have been negative 4 times x minus 1, x minus 2. Right? And now, what is the next step that you should be doing? Well, now what I should be doing is that I should be simplifying, right? And like we did before, you can FOIL them. You can FOIL the binomials that you have. So what I'm going to do is I'm going to go ahead and FOIL. X times x gives you x squared minus 2x plus x minus 2 minus 4, x squared minus x plus x minus 1. I'm going to do the same thing for the denominator that we have in there, right? So it's 5 times x squared minus x plus x minus 1. And I'm going to do the same thing in there as x squared minus 2x minus x plus 2, right? And when you do that, you can obviously combine the like terms and then distribute at the same time, or you can combine the like terms in one step and then distribute in the second one. It doesn't really matter. But I will combine and distribute at the same time. So that gives me 3x squared. So what I'm doing is essentially I'm distributing the 3. And then I know that if I combine this, I should get x, like negative x, right? And negative x times 3 is negative 3x. And now negative 2 times 3 is negative 6. Minus
Isn't
4.
it negative 2x plus x is negative 1x?
Yeah, and what is negative 1x times 3?
Negative 3x.
Yeah, I'm distributing this 3 at the same time. Yeah, like I said, you can obviously do them in like 2 different steps, but I try to like combine and then distribute at the same time. If that was confusing, then you obviously can do it in like 2 different steps, okay? And now I'm going to do the same thing. I'm going to distribute, and I know that I can combine them, right? X minus x, they should cancel out. They should give me 0. And 0 times -4 is what? 0 times -4 is just -0, right? And then -4 times -1 is just +4. And in the bottom, I do the same thing. I'm trying to combine and distribute at the same time. Well, I know that 5 times x squared is 5x squared. And I know that these will cancel out because they're the same thing with just the opposite signs. And then I know that -1 times 5 gives me -5. I do the same thing with this part in here. I distribute the -4. That should give me -4x squared. And I know that I can combine them. -2x minus x gives me -3x. And -3x minus -4 is +12x. And I don't know that -4 times 2 gives me -8. Now what do? I look for common terms. 3x squared, -4x squared, right? And then what else do I see as my common term? Well, I see -6 and +4. I can combine them. And in the bottom, I see, what do I see in the bottom? Well, in the bottom, I see 5x squared, -4x squared. And I also see -8 and -5. I can combine them. So like, let's combine, right? If I combine the top, 3x squared minus 4x squared is -x squared. And then I said that -6 and 4 are like terms, so we can combine them. That should give me -2. And in the bottom, 5x squared minus 4x squared should give me x squared. And then -5 times I apologize, -8 times -5 should give us what? -13, right? And then I still have the 12x in there, which is what I'm gonna write in there, right? So now, if you take a look at it, what do you see? I see a lot of things. I apologize, I missed out the 3x in here. There was a 3x in the top. So yeah, so now I see a trinomial in the top and a trinomial in the bottom. And now what do I do with them? So now, before I factor the trinomial in the top, what I'm going to go ahead and do is that I'm going to factor out the negative sign. And so I'm going to do x squared plus 2 plus 3x. And then in the bottom, what I'm going to do is that I'm going to keep it the same. I'm going to keep it the same denominator, right? And now I should be able to factor them. And how do you factor the top? So for the way you actually factor this, so I factored out the negative sign, and the 2 binomials that I'm supposed to get is x plus 2 and x plus 1, right? Because 2 plus 1 gives me 2 plus 1 gives me 3, and then 2 times 1 gives me 2, right? So now I also factor my denominator. And what are the 2 binomials that you get when you factor that trinomial? Well, you're supposed to get x minus 1 and x plus 13. And you do not see any common factors in the bottom or in the top that you can cancel out, and hence that is your final answer.